All right, guys. This will be the sixth lesson and the first one of this week, guys. And so we're just going to hop right into it. We're going to continue with our unit here. So our next topic is function operation. So we will see addition, subtraction, multiplication, and division. And then once we've gotten our final answers, we're going to be finding what the domain is for those. And I'll show you how that we can solve for that. All right. So the first thing we'll need to know. You can add, subtract, multiply, and divide functions based on how you perform these operations for real numbers. That's a key thing to understand, guys. And today, we're looking for real numbers. One difference, however, is that you must consider the domain of each function. So below is a list of the operations, how we can get from one to the other. Again, I would really recommend you writing from f plus g of x into f of x plus g of x. And with subtraction, multiplication, and division, same way. Key thing for division, though, if we have a denominator, we have to solve for g of x, solve for x, and that once whatever we find what that is, right, that cannot equal 0. So you always set that equation equal to 0, solve for it, and then that tells us what our domain cannot be. That's the key thing for division. So the domains in the sum, difference, product, and quotient functions consist of the x values that are in the domain of both finding f and g. Also, the domain of the quotient function does not contain any x value for which g of x equals 0. So again, our denominator and our divisions cannot equal 0. So main things we have to focus on, okay? All right, first one we're looking at is adding and subtracting functions here. So let f of x be 4x plus 7 and g of x be the square root of x plus x. What are f plus g and f minus g, and then what are their domains, okay? So our first step, we're going to be doing f of x plus g of x here. So f of x plus g of x. All right. Then we're going to plug in those values there. We know what f of x equals. That's 4x plus 7. G of x is the square root of x plus x. So I'm just going to replace those values. So instead of f of x, we're going to write 4x plus 7. And g of x, I'm going to go and leave this in parentheses, just kind of remind me here. And g of x is the square root of x plus x. The main thing we want to remember here, guys, is that we always want to add. So in this case, since we're adding, all we're going to do is just combine like terms here. So I do have x's that I can combine. Even though it's a square root and it is an x, it's on the inside there. So it's a different type of term. So I cannot combine that with the other terms there. So 4x plus x would give me 5x. Then we have plus the square root of x plus 7. Okay. Now we're going to do the same thing for our subtraction here. So then it would also be f of x minus g of x. And this one we have to be careful on. When I substitute, I'm just going to plug in first. So we should have 4x plus 7 minus the square root of x plus x. Okay. Anytime we have subtraction, we're going to use our method of KCF, keep, change, flip. So keep the first term the same. So the first term should be 4x plus 7. We're going to change the sign from subtraction to addition. And then we're going to flip the signs. That means this will become a negative square root of x, and that'll become a negative x. Okay. From there, combine your like terms. So again, here are my x's. 4x minus x would give me 3x. And we have a negative square root of x and a plus 7. Now, again, it's asking for our domains as well. So anytime we have a square root in there, guys, we have to set the inside part of that equal to 0 and solve for that. So again, since it's just x, we would set x equal to 0. Now, again, in our square roots, we're looking for real numbers. That means if I have a negative on the inside of a square root, then that means it's not a real number. It then becomes imaginary. So we have to have numbers that are going to be bigger than 0, which means since we have a square root in both of those there, the domain for both of these is going to be that x has to be greater than or equal to 0. And again, all we did to get where x, that number of 0 was, I just took that x right there and set it equal to 0. Okay. Since there's nothing I'm solving for x is already by itself. That's where that 0 came from. Okay. So anytime we have a square root, set the inside equal to 0, solve for x. All right. And that'll tell you what it needs to be bigger or smaller than depending on those numbers. Okay. All right, example 2. So multiplying and dividing now. All right. So first step, let's go ahead and write multiplication here. So it's just going to end up being f of x times g of x. Right? We substitute our values here. So it's going to be x squared minus 9 times x plus 3. And again, since we have two terms here, we're going to FOIL that out. So if you want to take some time, pause the video, go ahead and FOIL this out. So x squared minus 9 times x plus 3, when worked out, should give us, I think I have it right here. Let me check. That should give us x cubed plus 3x squared minus 9x minus 27. Okay. So luckily for us here, we don't have a denominator, which really helps us out here. Now, I don't see a radical and I don't see a denominator. Those are the two things I check for my domain. Since I don't see those things there for multiplication, your domain should be that x is going to be the set of all real numbers. All real numbers. Okay. For division here, we got to be really careful here. So f of x over g of x. So this is one we have to be careful on. So again, same thing. We're going to go ahead and plug it in. So we have f of x on top. So it's going to be x squared minus 9 on top. X squared minus 9 on top. And then we have x plus 3 on the bottom. First step, let's go ahead and factor what we have here. So x squared minus 9 is a perfect square on both terms. So if I were to factor that, that would be reduced down to x plus 3 and x minus 3. All over x plus 3. So when simplified here, since I have an x plus 3 on top and bottom, those should end up canceling out, which leaves this reduced form equaling x minus 3. Now, if I go back to that original equation I had, though, there was a denominator. That was x plus 3. So this is going to be key for my domain here. So I'm going to set this x plus 3 equal to 0. So I'm going to set x plus 3 equal to 0. Okay, solve for x. So here, x is going to equal negative 3. So again, this is what x cannot equal, because in my denominator right there of x plus 3, that's going to give me a 0, and I can't have 0 on the bottom part of my fraction. So for my domain, all we write here is that x cannot equal negative 3. But again, in simplified terms there, x minus 3 is our answer. So those are your two answers for the division. And this one was the one for multiplication right here, where your domain was the set of all real numbers. All right. Composite functions here. Next topic. The diagram shows what happens when you apply one function of g of x after another function, which is f of x. The output from the first function becomes the input for the second function, and when you combine the two functions, as in the diagram, you form a composite function. We've kind of covered these before, guys, so I'm going to go ahead and kind of show you an example. It's going to kind of ring some bells here. This is a good kind of refresher for us. So the composition of functions. I really like this layout here. So this is how we've done our problems before. So if we ever see like a little circle in between those two variables, so like this one we have a g of x, right? Our first step is to rewrite it. Which letter is closer to the x? In this example, it's the f. That's why f is on the inside there. So the letter that's closest to the variable, or our x pretty much, is going to be the one on the inside there. So it's g of f of x. So then your first step would be to value f of x first, solve for that equation, get it down to that number, and then whatever that answer is, that's what you're going to plug in for that g equation. So it's going to be g of the new answer, which is whatever f of x came out to equal. Okay? And it'll make sense as we work on here. So let's take a look. So on example 3, let f of x equal x minus 5 and g of x equals x squared. What is g of f of negative 3? So my first step, rewrite the equation here. So again, if I ever see that little circle there, my first step, rewrite it. So it's going to look like this. Since f is closer to negative 3 there, then it's going to be g of f of negative 3. That means I'm solving first for that f of negative 3. So I'm going to pull that out and solve for that first here. So f of negative 3, which means I'm solving for f here. So the equation for f is x minus 5. So x minus 5. Now my next step is to plug in that negative 3 for any of my x's that I see there. So it's going to equal negative 3 minus 5, which equals negative 8. Again, you should get a number for these type of problems here. So f of negative 3 equals negative 8. So now I'm going to substitute that in for f of negative 3. So now I'm solving for g of negative 8. And again, g of negative 8, I'm going to use that g equation, which is x squared. So x squared, plug that in for x. Now, anytime you have a negative number and you have an exponent, put it in parentheses. So it should be negative 8 in parentheses squared. So that's negative 8 times negative 8, which should give us a positive 64. Again, if you did not put that in parentheses, it would give you a negative, which would have been the wrong answer. So make sure you're careful about those negatives and that they are in parentheses. All right. Next example here. Using composite functions. So you have a coupon good for $5 off the price of any large pizza. You get a $10 discount on any pizza if you show your student ID. How much more would you pay for a large pizza if the cashier applies the coupon first? So again, this one we're going to label some variables here to kind of help us out. So our first variable we're going to label is the cost of the pizza. What does it cost for just a large pizza? Okay, so we're going to say that's going to be x. So x equals, we'll just say large pizza, or I'll just say pizza. That's the cost of the pizza. Okay, so now we're going to have labels for this here. So we're going to say for our next one here, we're going to do the coupon. So I'm going to do C for coupon. So for my coupon here, that one's going to be C of x. So C of x, the coupon with the pizza. And then, so the way we're going to write that is that if I did the coupon was $5 off. So it's going to be C of x equals x minus 5. We're taking $5 off the cost of the pizza. So x minus 5. Then the next one would be if we had the discount. So for our discount here, we're going to do D of x. So D of x. And the D of x, our discount of our pizza here is 10% off. Okay, so to solve for that 10% off, you're going to start with the original cost of it, which is going to be that x. That's the full cost of it. And then take away 10%. So 10% written as a decimal is going to end up being 0.1x. We are subtracting 10% off. Again, since these both have an x, I can't subtract those. So that would simplify down to 0.9x. 9x. So pretty much you're only paying for 90% of the pizza. That's what they're saying there. So from here, we need to find the two values. So again, it's asking for how much more would you pay for the large pizza if they applied the coupon first. So essentially what we're doing here is we're setting up two different composite functions here. So let's take a look at what that's going to look like here. Okay. The first composite function is if we do the discount, then coupon. And then the other way would be if they did the coupon, then the discount. Okay. So if they did the discount, then the coupon. Okay. So that means that the coupon would go first because the discount is going to go first. So in this equation that we're setting up here, we're going to rewrite this as coupon of discount, and you'll see why I'm writing it this way here in a second, of x, which means the vice versa way would be discount of coupon of x. So the reason I kind of flip the order here is when I go to rewrite this here, again, this D is closer to X. So that means the C goes on the outside and the D goes on the inside. Same over here. The D would go on the outside and then the C would go on the inside. But again, if we're doing the discount first, that means the D has to be on the inside there. That's why I had to flip the order there. So for this instance here, when I write my equation, it's going to be C of d of x, if I go back to what that looks like up here, we said that d of x equals 0.9x. So I'm going to plug that in right here. So c equals, or c of 0.9x. And then if we go back there, the equation for c was x minus 5. So if I go back in there, it should be x minus 5. Again, plug this value in for x. So that should be 0.9x minus 5. X minus 5. Okay. If I work this other problem out, I would plug that in for c of x. We know that c of x is x minus 5. So we're looking for d of x minus 5. And then that d equation is 0.9x. So all we're doing here, I don't know why I put that little line there. All we're doing here on this one is just plugging in x minus 5 there. So essentially, we're just multiplying 0.9 times x minus 5. Which again, when I work that out, would give me 0.9x. And then 5, or 0.9 times negative 5 gives me a negative 4.5. Okay. From here, again, we're going to take the discount one first, and then we're going to take the coupon first and subtract those two. So essentially, we're going to end up subtracting this minus that. So I'm going to plug that in here. So it's going to end up giving me 0.9x minus 5. Oh, wait, I think I flipped that. Yeah, it should be, I flipped that first. Okay, 0.9x minus 4.5 minus 0.9x minus 5. Okay, so again, with subtraction, I'm going to distribute that subtraction into both. So the first one stays the same, so 0.9x minus 4.5 plus 0.9x plus 5. Oh, that should be a minus 0.9x because that was already positive to begin with. Which essentially, all we tell here is that the 0.9 should cancel. And when I combine negative 4.5 with a positive 5, that tells me it's going to be a 50 cents difference. So essentially, to answer the question there, how much more would you pay for a large pizza if the cashier applies the coupon first instead of the discount? It would cost you 50 cents more at the end of the day. Okay. All right. So with that, guys, we do have homework. All right. It should already be up online on Math Excel. So again, make sure you are working on that. That's going to be due. I don't know why that says Friday there. It's going to be due tomorrow. Okay. So your homework is due on Tuesday at 11:59. I don't know why that says Friday. It must have been a typo on my part. Virtual office hours. That's again posted in LMS. So again, if you don't know where the link is for it, go to LMS. Again, questions or concerns about anything, please email me. I'll get back to you as quick as I can. All right. If you need anything else, guys, I'm here for you, and I hope you are enjoying your time at home with your family, guys. I'm here for you if you need me.